Hey, Tapping Life Math Industry, and we are going to take a look at a new unit in the geometry part of it, ratios and proportions. So you probably heard about these two things earlier before you got into high school. And let's review what that even means. So when you think of a ratio, you're talking about two numbers that can compare things. And that is actually correct. We can represent it in many different ways. We can represent it as a fraction, like 2 over 5. We can represent it as a colon, 2 to 5. You would normally see this version if you were playing a sport, like a soccer match would be the final score is 2 to 5, if you ever watched the World Cup. And the last way we can say it is similar to the second one, but we literally just have the word 2 in it. But you won't really see this in math unless you're doing some kind of word problem. So these are three common examples where you would see ratios. And it means that you have two pieces of data that would be compared to each other. Not only that, but it can be the expressed quotients of the number. The word quotient represents that you're dividing by something to get something that is proportional. So we looked at ratios, and it's kind of self-explanatory what a ratio is. Well, what does the word proportions even mean? So when you think of the word proportions, or when you think and hear that something is proportional, you probably heard of this kind of equation. And that is an example of a proportion because it has two or more ratios that are equal. We said earlier that a fraction can be a ratio and another fraction can be another ratio, but a proportion means that there are two or more ratios that are equal. Going back to ratios and proportions, they can be used in real-life examples. Well, for example, if you're needed to go somewhere and you don't know where to go, you use a map. However, a map is not in a 1-to-1 ratio, like this world map on the top of my bed, or above my bed. There's no way that we're going to make a world map the size of Earth. Well, Earth is a geometric map. So what else we can say is if we want to measure that map and put it to scale, we're going to say that 1 inch is going to represent 40 miles, for example. Or another example, you know how I like to collect things? Well, if you didn't know, now you kind of do. So collector's items can also be used with ratios and proportions. So what the person did, this is Hallmark, they make these ornament train cars. And what they do is they have the real model, then they would shrink it down to scale, but it would still be around proportionally, but to scale correct. So what it means is they would take a really big giant train car, then use math to redesign it and shrink it down to this size. If this thing was the actual thing, it would be very, very big. And that's why we have trains, like we have N gauge, O gauge, maybe there's a G gauge, because they all represent, if it was the real thing in real life, it would be very, very big. And that's why they have different ratios. Like this one may be 1 to 250 by scale, maybe this. So now we got a really quick idea of what ratios and proportions is. And now we understand and reviewed what that was. Now the question is, how can we apply this with math? So remember when we saw that equation where we had 1/2 and 2 over 4? If we say 3 over 5, and we're going to say 4 and we're going to make a proportion. What is going to be x? Well, what we can do is solve this algebraically. What we can do is cross multiply. If we cross multiply, we're going to get 20x is going to equal 20 is going to equal 3x. So we're going to put that down here. 20 is going to equal 3x. Because 5 times 4 is 20, and 3 times x is 3x. Divide this side by 3, and divide this side by 3. And we're going to get an answer as x is going to equal 6.66 repeating. So if we put that into x, it would make these two ratios proportional. Hang on. What is that even called? We know how to find the ratios, and we know how to find the letter x. X marks the spot. But what is that called in mathematics? Well, it's called the means extremes product. It's literally called that. The means extreme product. If proportions, in the proportions, the product of the means is equal to the product of the extremes? Wait, hang on. We understand that the means extreme product theorem is saying how to find x and how to find and make it proportional. But hang on. Where do we get the words product, mean, and extreme? Like, what's so extreme about this kind of math? Well, there's some kind of formula or some kind of format on how we like to see this kind of problem. So if you remember from middle school, you probably learned about different kinds of graphs. So we have the x and the y-axis. And mathematicians like to use a system where you understand what quadrant you're in on the graph. We can say quadrant 1, quadrant 2, quadrant 3, and quadrant 4. However, these would be in Roman numerals. We can do the same thing. We're going to say this as a proportion. 3 over 5 and 5 over 15. And not only we can put numbers in them, but if you ever solve a word in math, we're going to say that the number 3 is going to represent the first number. Then we have second, third, and fourth. Similar to quadrants on a graph, but it's different. To understand where everything goes, the two words extremes and means are actually what set up the butterfly strategy, or when we do the crisscross method. Why? Well, we're going to say that the first and fourth numbers are going to represent the extremes, while the third and the second numbers are going to represent the means. And it's a way on what we can do to indicate what we're multiplying with. And hey, to make an association, this looks like the politics system, the political graph, or the political spectrum, because it's shaped like a graph. We have left, right, authoritarian, and libertarian. Because it's relatable, because we have extremes and memes. So the most extreme forms are the first and fourth numbers, and the mean ones are the second and third numbers. So that is how we understand the means extreme product. So it's saying on how we get to x and why it works. Because when we're multiplying, that is going to be proportional to each other. So what we're going to do is say, about this proportion, 2 times 9 is 18, and 3 times 6 is also 18. So they are equal. So that's why it works. I hope this video has helped you learn about ratios and proportions. Thank you for watching Top Opinion Line's Math Industry. Like and subscribe.